Alright guys, so let's talk about square roots. Remember when we had something to the second power that was called the square of a number? So for instance, here we have 3 to the second power, that would be 3 squared. Square roots are kind of like a reverse exponent when it comes to things to the second power. So when I ask you what the square root of 9 is, what I'm asking you is, what squared gets you 9? And that would be 3. So numbers like 9 and 4 and 16 are called perfect squares since their square roots are integers. So cube roots are similar to square roots except they deal with things to the third power. So if I were to ask you what the cube root of 27 is, that would be asking you what to the third power or what cubed would get you 27, and that would be 3. So like exponents, there's some shortcuts you can apply to square roots. For instance, here you have the square root of 4 times the square root of 25. Now what you can do is combine these and bring them under the same square root. So here you have the square root, parentheses, of 4 times 25. In a similar way, you can take the square root of 4 divided by the square root of 25 and bring the division, or the fraction, underneath one square root. Another shortcut is if you have the same root here, the square root of 4, and you're adding them, you can actually add these numbers in front together. So 3 the square root of 4 plus 2 the square root of 4 will equal 5 the square root of 4. Sometimes you'll encounter roots that need to be simplified. For instance, here we have the square root of 24. Now if you were to get that as an answer, that couldn't be accepted. You would need to simplify it out. 24 isn't a perfect square, so what we'll need to do is break it down into its roots. So, as you can see here, we take 24 and we break it down to factors of 8 and 3. After that, you'll need to break down the 8 even further. So what you can do is break down the 8 into 2 times 2 times 2 times the remaining 3. Now with square roots, what you can do is if you see factors here, for instance 2 and 2, two 2's, you can bring one of those 2's out and cancel the 2's on the inside. So what we get left with is 2 to the square root, or 2 times square root of 6, 6 being 2 times 3 that are left over. So another instance of an answer that would need to be simplified is a fraction where you have a square root in the denominator, or in the bottom of the fraction. So here we have 7 over the square root of 3. A way to simplify this, or a way to make it an acceptable answer, is to move the square root. Now the easiest way to do this would be to multiply it by, in this case, the square root of 3 over the square root of 3, which is the same as 1, which is why we're allowed to do this. So what we get is 7 over the root 3 times root 3 over root 3. And now what happens is, since you have the square root of 3 times the square root of 3, that equals 3. And on top we get 7 times root 3. And that would be acceptable as an answer. So moving on to fractional exponents. Fractional exponents combine elements of exponents that we've learned about earlier and the concept of roots, which we just learned. So here we have x to the 1/2 power. That just translates to the square root of x. So if you were to think about it, take the fraction, whatever is in the denominator here will tell you what kind of root you're taking. So for instance, if this were x to the 1/3, that would equal the cube root of x, and so on and so forth. In this next example, we have x to the 3/2. Now what that signifies is, like in the previous example, we have 2 in the denominator, which means we're dealing with a square root. The 3 on top here will signify what power you're taking x to underneath that root. So we get here the square root of x cubed. So if we were to have another example of this, we could take x to the 5/3. That would mean we have a cube root, right? The bottom of the fraction is 3, so the cube root of x to the 5th. So another topic regarding exponents you might encounter are negative exponents. Now all you need to do when you encounter an exponent like this is take the reciprocal of the base. So we have x to the negative 7. All that means is 1 over x to the 7. Same goes for 2 to the negative 3. 1 over 2 to the 3. And in this case, we have a fraction, 3 over 7 to the negative 2. So instead of it being 3 over 7, we have 7 over 3 to the second power. Alright guys, so that's pretty much it regarding exponents and roots. Feel free to leave questions and comments below, and like the video if you found it helpful. I'll be releasing more videos covering other math topics from the SAT and ACT in the near future, so subscribe to the channel to stay on top of any new videos that might be coming out.